This is a video on single sphere rebounds in the vertical direction. We'll go straight to some questions. This one is from 2015 and it's an ordinary level question. So a ball is dropped from rest from a height of 3.2 meters onto a smooth horizontal floor. The ball hits the floor, rebounds to a height of h meters above the floor. The coefficient of restitution between the ball and the floor is 3/5. Find 1, the speed of the ball when it hits the floor, and 2, the value of h. So this question needs to be broken down into 3 sections. The first one is the free fall section from rest, where the ball falls through 3.2 meters. Then the ball rebounds off the floor, that's the second part of the problem, where the velocity after divided by the velocity before it hitting the floor equals minus the coefficient of restitution. And the third part of the question is when the ball rises up after hitting off the floor and reaches a maximum height. Okay, so let's go to the first section. So if it's dropped from rest, u is 0, the acceleration is 9.8, it travels a distance of 3.2, and we're looking for v, the final velocity before it hits the ground. So v squared is u squared plus 2as, and we get a value there of 8. Just to draw your attention to the 10, you should have 9.8 there. So that acceleration due to gravity value has been rounded to 10 for simplicity. Right, we go through the question. So the next thing that has to happen is the ball rebounds off the floor, and we need to find the speed after rebound. Once we have that, we go on to the third part of the question, which is the ball rising up, where the final velocity equals 0. So let's have a look at the speed after rebound. The velocity after rebound is equal to e times the velocity before. There should be a minus here, but we're dropping it for simplicity. So if we do that, we have EV, which is the velocity after, E being 3/5 multiplied by the velocity before, which is 8, gives me a velocity of 4.8 meters per second. So now we know the initial velocity in the third section, which is the ball rising up. If we apply the final velocity is 0 at the maximum height, we can use v squared is u squared plus 2as again. Once more, we should have minus 9.8 rather than minus 10. It's rounded, and you get a h value of 1.152. Okay, second question. Now pause the video here, try the question yourself, but I will keep going and go through it. So from 2016, a ball is fired vertically down with a speed of 2 meters per second. So its u value is not 0, it's 2. The height in this case is 3 meters. Again, it hits a smooth horizontal floor. The ball hits the floor and rebounds, and then it rebounds to a height of 1.8 meters. That'll be the maximum height, so it's going to stop at that height. Coefficient of restitution is e. Find the speed of the ball when it hits the floor and the value of e. Part 1 is identical to what we had previously. V squared is u squared plus 2as. 2 squared is 4. G is rounded at 10 in this case, so you should get a value slightly less than 8. Part 2, find the value of e. Once more, the velocity after is e times the velocity before, so it's e times 8, and we know it travels a distance of 1.8 meters coming to rest at the highest point. So v squared is u squared plus 2as again. It's identical to the previous question. You should have gotten roughly 3/4. It might vary if you put in a different value for g there, if you put in g is 9.8, which you should do anyway. Final example. Again, pause the video and attempt the question yourself before we go through the marking scheme. I'll plough straight on. A ball is fired vertically upwards from the ground with a speed of y, so it just reaches a height of 5 meters. Find the value of y. Okay, so for that one, we know at the maximum height it comes to rest. We know there's a height of 5. We know the acceleration due to gravity is minus 9.8. So v squared is u squared plus 2as will be used in that case. Part 2. The same ball is then fired vertically downwards with a speed of x from a height of 2 meters and just reaches a height of 5 meters after rebounding from the ground. The coefficient of restitution for the impact between the ground and the ball is 10/11. Find the value of x. Again, it's identical to the previous 2 questions. The initial velocity is x. S is equal to 2 meters, and we know acceleration downwards is 9.8. So you get the velocity before it hits the ground, Then you'd apply the velocity after it rebounds is equal to E times the velocity before it hits it, which is the velocity that you got in the first part there. And then you would use that velocity. The displacement upwards is equal to 5. It comes to rest, so the final velocity is 0, and the acceleration is minus 9.8. So you can check it there based on those calculations.